In May 2020, a team of investigators at a ranch in northeastern Utah announced they had found something buried.
We have a 1,000-foot-long, oval-shaped object that appears to be buried underground at Homestead Two.
Possibly, they said, a two-story facility. The following week, they brought in a drill rig and put 2 holes into it. 17 feet of siltstone in the first hole, 29 feet of ordinary clay in the second. Every core was screened for radiation, and every core came back at background.
Nothing there. Got nothing.
And on site, one man says the quiet part out loud.
But this doesn't seem like it adds up to what we were thinking.
That is a falsification test. They made a specific claim about a specific place at a specific depth. They went and looked. The claim did not survive. In a working science, that is the most valuable thing that happened all season. You learn more from the prediction that breaks than from 10 that hold. And that one hedged sentence is the whole of it. Nobody asked why the radar had produced a structure that was not there. No revised depth, no second survey, no new target. The line is left where it fell, and the season moves on. 8 episodes, around 40 distinct factual and physical claims. We checked all of them.
A word first about what this is and what it is not.
We are not judging this as television. As television, it works. It is well made, and the people in it are likable. We are judging it against the standard it sets for itself because the program uses the vocabulary of science constantly. Data, triangulation, measurement.
There is some phenomena occurring, and we have measured the phenomena. The phenomena is real.
That is a scientific claim. It gets assessed as one. Second thing, and it matters. Nothing in this episode requires anybody to be lying. Travis Taylor holds 6 degrees, 2 of them doctorates: electrical engineering, physics, optical science, aerospace engineering, astronomy. Jim Segala has a genuine physics doctorate, with published work in medical dosimetry. Eric Bard studied physics at Brigham Young and helped develop archival optical storage. These are not invented experts. Almost everything we are about to go through is what happens when capable technical people work quickly, outside their own field, on camera, with consumer instruments, and without anybody in the room whose job it is to say no.
And before any of the specifics, there is one structural fact that governs all of them.
In 8 episodes, they never took their instruments off the property. Not to a neighboring ranch, not into town, not anywhere. And they clearly know what a reference measurement is, because they use one. When the drill cores come up in episode 6, every sample is screened against background, and the word background is spoken 6 times. That is the concept, used correctly. They simply never applied it to the thing the entire season rests on, whether the numbers on that mesa differ from the numbers 10 miles down the road. A number is only strange if you know what normal looks like. They never went next door to find out.
Episode 1. Travis Taylor arrives, is flown over the property at 10,000 feet, and walks the mesa with a handheld meter.
Dude, it's in the milliwatts per meter squared. That's a significant amount of energy right there. The amount of energy in these microwaves we were measuring was getting close to dangerous levels. Microwaves like that just don't exist in nature.
Start with that last sentence, because it is the one everybody wants to jump on. And jumping on it is a mistake. Read what he actually says. Microwaves like that. He isn't saying nature doesn't produce microwaves. Of course it does. He's saying nature doesn't produce that much microwave energy at ground level in that environment. And that's a reasonable claim. The meters on the mesa were reading 4.5. and one of them apparently pegged at 20. The highest documented reading in the series is 18.9, while the narration gives 20. So let's use 20. That's the most generous number for their case. And 20 milliwatts per square meter is far above the natural radio background you'd expect at ground level. But there's an important distinction. Unusual doesn't mean dangerous. 20 milliwatts per square meter by itself does not demonstrate a health hazard. The interesting question isn't whether the reading was dangerous, it's where the signal came from.
So where did it come from?
Well, look at what was standing next to the meter. People carrying radio transmitters. Professional wireless microphones can transmit hundreds of milliwatts of RF power, depending on the equipment. And RF power falls off rapidly with distance. Take a 100 milliwatt transmitter and a simple dipole antenna. At 1 meter, you're in the neighborhood of 13 milliwatts per square meter. At half a meter, about 50. And at a foot, roughly 145. That's from one transmitter. There were several people wearing them, and those weren't the only transmitters on site. There were crew radios, intercoms, a weather station, and other electronic equipment operating in the same general RF environment. So before we start looking for exotic explanations, there's a much simpler question. What happens when you turn the transmitters off? Because that's the test that matters. Distant radio transmitters are another possibility. But distance matters. A 5 kilowatt station 4 miles away, for example, produces only about 17 thousandths of a milliwatt per square meter at the ranch in a simple free space calculation. That's tiny compared with a reading of 4.5, let alone 20. So the distant transmitter is unlikely to explain the measurement. A transmitter standing 3 feet away, that's a different story. And that's the point. The reading may have been real. The radiation may have been real. But neither fact tells us where it came from. Before invoking something extraordinary, you test the ordinary sources first. And the people standing next to the meter were carrying some very ordinary RF transmitters.
Which brings us to close to dangerous levels.
Let's put 20 milliwatts per square meter into perspective. I'll use 900 megahertz, which gives us a conservative comparison. The ICNIRP guideline for public exposure at that frequency is 4,500 milliwatts per square meter. 20 is about 1/225th of that, so we're nowhere near the guideline. And that guideline already includes a substantial safety margin. So 20 milliwatts per square meter does not mean dangerous. It means measurable. Those are two very different things.
But there's another problem, the meter itself.
The tri-field TF2 can measure RF only up to 19.999 milliwatts per square meter. So when it hits the top of the scale, we don't know that the field was 20. We only know it was at least that high. It could have been 20. It could have been 30. The meter can't tell us. And that's important, because a meter hitting its maximum is not the same thing as measuring the maximum. You can't use the ceiling of an instrument as the measurement.
Taylor then offers a conventional explanation. Nuclear fallout carried east from Nevada.
Back during the Manhattan Project, as long ago as 1945 and on through the early 50s, a few hundred miles away, at the Nevada test site, there were above-ground nuclear tests, meaning atomic bombs were set off.
Credit where it is due, and this is real credit. That is an attempt at a mundane explanation. It is the most scientifically respectable instinct anybody displays all season. He is actively trying to explain his own anomaly away. Now, the sentence itself. There were no nuclear detonations in Nevada during the Manhattan Project. There were none in Nevada in 1945. Testing at the Nevada test site began on the 27th of January, 1951. And it did not end in the early 50s. Atmospheric testing there ran until July 1962. 3 errors in one sentence. The distance is right. It is about 400 miles.
When they were doing that down in Nevada, the Uinta Basin was actually a hot spot for the downwind.
Careful here, because there is something real underneath it. The Centers for Disease Control published a ranked table of the 80 highest dose counties in the country, out of about 3,100, and Uinta and Duchesne are both on it. That is genuinely the upper percentile. But look at the numbers. Uinta, 0.7 of a millisievert. Duchesne, 74 hundredths. The national maximum in Nye County, Nevada, is 3. They sit at about a quarter of it. In Utah County, Wasatch and Toole all scored higher, inside the same state. The people the United States government formally recognizes as downwinders live 260 miles away, in the southwest corner of Utah. When this episode aired, Uinta and Duchesne were not on the compensation list at all.
Some of the highest concentrations measured, if I understand right, were just 30 miles north of here.
30 miles north of that ranch is the south slope of the Uinta Mountains, Ashley National Forest, on the approach to a designated wilderness, uninhabited high country. There is no published fallout measurement there of any kind. He hedged it with, if I understand right. He was right to hedge.
And what is left in the ground today?
True, and true everywhere. Cesium-137 from nuclear weapons testing decades ago is still in that soil. It's in soil all across the United States. So fallout is a reasonable thing to consider. But it's the wrong size by about 1,000. It's real. You can measure it in the laboratory. But at ordinary fallout levels, it's far too weak to explain a large field reading.
And then he extends it.
It's possible that exposure to radioactive fallout could cause people to have strange symptoms, maybe even hallucinations, and see things, hear things.
This is where it stops being a reasonable instinct. Radiation can cause severe neurological effects, but at extraordinarily high acute doses. The cerebrovascular syndrome occurs at doses measured in tens of grays and is rapidly fatal. That is nothing like the environmental fallout we're talking about here. There is no credible evidence that ordinary environmental cesium-137 exposure produces hallucinations in otherwise functioning people. And the residue we're actually talking about is a tiny amount of cesium in the topsoil, the same kind of fallout found across the country. It's real, it's measurable, but there is no evidence that exposure at those levels causes hallucinations. He reached for a boring explanation, which was right, and then asked it to do a job nothing that small can do.
Episode 2. Outside contractors sweep the property for radiation, radio frequency, and chemicals. At a sinkhole above Homestead 2, they report volatile organic compounds.
About 3,600 parts per billion, which is a really high abnormality. Dangerous levels, certainly.
3,600 parts per billion is 3.6 parts per million. Against occupational exposure limits for the common solvents that reading would represent, that is on the order of 1/30th of a workplace limit. Dangerous is the wrong word, by about a factor of 30.
Oxygen was reported normal. Travis Taylor then entered the cavity, lost his balance, and reported his knees trembling. The show presents those symptoms as unexplained by the oxygen reading.
This is the one place where the show is standing next to a genuine hazard and gets it wrong in the other direction. An oxygen meter measures oxygen. That's it. You can have a normal oxygen reading and still have dangerous levels of another gas. Carbon dioxide, for example, is heavier than air and can accumulate in the bottom of a confined space. A reading at the opening tells you about the opening. It doesn't tell you what's 10 feet below it. Dizziness and unsteadiness while descending into an unventilated void should be treated as a confined space warning sign. It has a name, a hazard class, and a safety procedure. The contractor's instinct was sound. Their testing wasn't complete. They needed to test the atmosphere at depth for oxygen, combustible gases, and toxic gases, including carbon dioxide and hydrogen sulfide. OSHA's confined space guidance specifically calls for this kind of atmospheric testing and monitoring.
The cavity was venting cold air, which the team found notable.
Cold air coming out of a hole isn't mysterious. Temperature and pressure differences can drive air in and out of underground cavities. It's common in caves and other underground spaces.
That night, a stakeout. A green laser aimed at the mesa returns as 2 points rather than 1. Later, the laser fails entirely. An infrared camera shows the mesa glowing and a beam rising from the ground that is invisible to the naked eye.
A mesa glowing in thermal infrared after sunset is exactly what you'd expect from rock retaining heat from the day. That's what a thermal camera detects. Had the mesa stayed completely cold, that would have been interesting. Now, the beam. They were using infrared cameras and night vision equipment that night. An infrared illuminator can produce exactly that. A beam invisible to the eye, but visible to an infrared-sensitive camera. I'm not saying that's what the beam was. I'm saying the program never establishes that its own equipment was ruled out. And that's the problem. An unusual image isn't evidence of something extraordinary until you've ruled out the ordinary explanations, including your own equipment.
Episode 3. The team wants to know where the radio energy is coming from. They place tri-field meters inside coffee cans to use the metal as a shield and give the meters a direction. They take bearings from 3 positions and intersect them.
There's a huge peak right now, 900 megahertz. It's 5,700 feet, 1 mile high.
We don't know how big those cans were. The show never says, and I'm not going to pretend otherwise. But we can still ask what the physics allows. At 900 megahertz, a cylindrical metal can needs to be roughly 20 centimeters across before that frequency can propagate through it as a waveguide. That's almost 8 inches. A typical coffee can is closer to 6 inches across. So at 900 megahertz, a coffee can is not a directional antenna. It can block some energy from the sides and create some front-to-back difference. But that's not enough to establish a bearing. And here's the problem. At higher frequencies, that same can become much more directional. At 2.4 and 5.8 gigahertz, common Wi-Fi and video link frequencies, the opening is large compared with the wavelength. So if the can seemed to point somewhere, the experimenters first needed to rule out nearby radio sources. Wi-Fi, cameras, drones, their own equipment. Because the can may not have been finding the anomaly. It may have been finding the crew.
Then the triangulation.
The farther away the source is, the more a small error in your bearing gets amplified. And the farther apart your measuring stations are, the better your triangulation becomes. But I don't know how far apart they stood. The ranch is 512 acres, roughly 1,400 meters across if you treat it as a square. So their baseline could have been anywhere from 100 meters to a kilometer. Run the numbers. With a 100-meter baseline and just 10 degrees of bearing error, a 1,700-meter target could be off by roughly 5 kilometers. At 500 meters, the error drops to about 1 kilometer. At a full kilometer, it's still about 500 meters. So the baseline matters. And the baseline is the thing they never tell you. But there's a bigger problem. 10 degrees is already generous. The can they were using had a beam roughly 130 degrees wide. Even if I give them a much more generous 30-degree bearing uncertainty, a 1 kilometer baseline still leaves an error of about 1,500 meters on a 1,700 meter target. In other words, for any plausible baseline on that ranch, the uncertainty is enormous. Yet they reported the result as 5,700 feet. Two significant figures, no plus or minus. And throughout the season, the measurements are presented without uncertainty.
And the frequencies themselves?
900 megahertz is right next to the 902 to 928 megahertz unlicensed band. That's a crowded part of the spectrum, used by all kinds of ordinary wireless equipment. So hearing a signal around 900 megahertz does not, by itself, tell us that the source is unusual. The other frequency they report is 5,480 megahertz. That's in the 5 gigahertz range, where Wi-Fi and some drone video links operate. And they were flying drones. A signal coming from above would be entirely consistent with a drone. The point isn't that we know these signals came from their equipment. The point is that they needed to rule that possibility out before calling the signals anomalous.
The team then launches a weather balloon through the altitude they calculated. Its telemetry stops at 10,453 feet above sea level, about 5,500 feet above the ranch.
That's right where the triangulation put it. I have flown this thing 30 times, more than 30 times. It's never failed on me.
One thing. The triangulation had an uncertainty measured in kilometers. So the balloon's failure still falls well inside the area they had predicted. It doesn't confirm the triangulation. They drew the target around the arrow. And 30 flights without a failure is not the evidence it sounds like. 30 consecutive successes still leaves a failure rate of about 1 in 10 inside the 95% confidence bound. 30 successes does not make a 31st failure anomalous. It is roughly what you would expect.
The episode also carries its most serious human claim. Thomas Winterton's head injury from 2 years earlier is assessed by a medical consultant.
Consistent with a radiation beam that entered his body from a specific angle of attack, back behind his head.
High-dose radiation can damage the skin. It can cause redness, hair loss, and, at higher doses, skin peeling. But those effects are not a fingerprint for radiation. A lump or swelling on the back of the head is not, by itself, evidence of a radiation injury. There are many ordinary causes, and an injury by itself cannot establish the angle of an alleged radiation beam. To establish radiation exposure, you would want dosimetry or biological evidence of radiation damage. None was performed. A scan reportedly showed little, and that was treated as compatible with the theory rather than as evidence against it. So we have an injury, but we don't have evidence establishing that it was caused by radiation, much less by a directed radiation beam.
Episode 4. A concrete sealed void beneath Homestead 1 is opened. Inside, ash, small white fragments, hair, and what the team describe as tissue.
It looks a lot like bones. They're too small to be anything in a human.
Too small to be human is not the test. Human bone can be small. It can be juvenile, cremated, or broken into tiny fragments. What matters is the bone's morphology, its shape, structure, and other features that can distinguish one species from another. That's the job of a forensic anthropologist. And that's not the analysis we see being done on screen. Eric Barr did identify one useful clue, and he reported it accurately.
Those are bone fragments. Well, and it looks like gnaw marks, too.
Gnaw marks can be consistent with rodents, although identifying what caused them requires closer examination. Ash, burnt bone, hair, and possible rodent damage under an old farmhouse all have ordinary explanations. I'm not going to pick one and pretend I know which. The point is that the evidence shown never rules those ordinary explanations out.
The team then escalates from balloons to instrumented rockets, carrying a gamma ray detector to about 1,000 feet.
At the apogee, this thing was screaming. We got closer to a gamma ray source as we flew into the sky. There was a concentration of energy above the ranch.
The inference rests on a stated rule.
Just to be clear, normally, anywhere else in the world, if you increase in altitude, you should see a decrease.
The obvious rebuttal is that radiation increases with altitude. That is true. It is also incomplete. Because there are two sources, not one. Cosmic radiation comes from above, and yes, it gets stronger the higher you go. But the ground under your feet is radioactive as well, and that is the source you are climbing away from. As the rocket rises, one source gets stronger while the other gets weaker. So over the first 1,000 feet, you cannot simply assume that the total reading should increase, which means Taylor called the direction correctly. He said the number should drop. He just had the wrong reason. He thought he was stating a rule about altitude. He was really describing the effect of moving away from the ground. And that is what costs him. When the number went the other way, he had no way of knowing which part of his reasoning had failed. So the only answer left on the table was that something was up there.
One more thing happens in episode 4, and it happens on the same day. The ranch takes delivery of about 40 head of cattle by truck, unloads them, sorts them, and runs them through a squeeze chute to fit tracking collars. Then the rockets go up.
They fired a rocket, and the cows ran. Livestock science has a word for that. It is startle.
Episode 5. Ground-penetrating radar is towed along the ranch roads and around Homestead Two. On the screen, a row of upside-down parabolas.
A football or a saucer, possibly a 2-story facility.
A hyperbola on a radar screen is not a picture of a buried object. The radar signal spreads out underground, so one object can show up across several points as the antenna moves past it. That creates the familiar hyperbola. The top of the hyperbola is the important part. It marks the point closest to the object, and the travel time helps estimate its depth. The curved sides are produced by the geometry of the radar signal. Processing called migration can collapse that curve back toward the actual target. Now, the geophysicist on screen knows this, and he says it himself without prompting.
Now, what creates the hyperbolas are objects. A lot of things can cause those. Boulders can cause those types of features. Tunneling can cause that type of feature.
That's correct, and notice the order. He starts with the ordinary explanation. It is the clearest piece of science in the episode, and it comes from the person there who actually does this for a living.
A resistivity survey runs alongside it. Dome-shaped features appear between 8 and 25 feet. The line is then rerun in reverse, and the features reproduce.
It looks more like a hollow opening than anything.
But resistivity can't tell you exactly what caused a feature. A resistive area could be a void, but it could also be dry sand, gravel, bedrock, or a different layer of rock. Hollow is one possibility, not a finding. and no actual resistivity values were presented. The reverse run does deserve credit. Repeating the survey helps check whether the measurements are consistent. It can reveal problems with the equipment or the electrodes. So this was a useful test. It was not theater. But here's the important part. Getting the same result twice does not prove what caused it. A real underground feature can repeat. So can an error caused by the survey geometry or the computer model. The repeat test tells you the measurement was consistent. It does not tell you that the blob on the screen is a shaft.
Then, the moment the season is remembered for. A covered hole at Homestead 2 is open. A dosimeter alarms.
Your max dose rate's about 120? Yeah, it's 120 something. My dosimeter device, which measures exposure to ionizing radiation, is showing that I just got hit with 120 millirads per second. That's like getting 20,000 full-body X-ray scans at an airport, which is 5 times more than the legal limit allows in a year. So, I just accumulated a semi-dangerous dose. So we're reading the exact same amount of rate, but this thing accumulated more.
Listen carefully to the words, dose rate. The instrument is reporting a rate, not a total dose. So let's do the simple math, because nobody on screen does. 120 millirads per second is about 4.32 grays per hour. If we're talking about gamma or X-rays, 1 second at that rate is already above the annual public dose limit. About 40 seconds would exceed the annual occupational limit. 10 minutes would put you into the range where acute radiation sickness can occur. And an hour would reach a dose associated with very serious, potentially fatal radiation injury. So semi-dangerous is a serious understatement. If that reading was real and accurate, nobody should have been casually standing over that hole and continuing the conversation. There is also a small problem with the yardstick itself. Backscatter X-ray scanners were pulled from American airports in 2013. By 2020, you were walking through millimeter wave, which is non-ionizing and delivers no dose at all. The comparison measures against something that had not existed in a U.S. airport for 7 years.
The following day, Taylor reports red marks on his hand and head, which he says a physician identified as radiation burns.
Radiation can cause visible skin redness at doses of around 2 grays. At the claimed dose rate, that would take roughly 28 minutes. Localized radiation burns are real. They can happen during procedures like fluoroscopy, where a concentrated beam puts a large dose into one small area. But an open hole in the ground is not a focused beam. If the radiation really delivered about 2 grays to both his hand and his head, you would expect significant exposure to the rest of his body as well. Taylor also reported nausea and a headache. If he had received a whole body dose of around 2 grays, doctors could have looked for evidence of radiation exposure in his blood. A falling lymphocyte count can help estimate radiation exposure. There is also the dicentric chromosome assay, a well-established test for radiation exposure that can detect much smaller doses. We never see either test reported. And a doctor cannot establish a radiation burn from red marks alone. Early radiation redness can look like an ordinary burn or sunburn. That matters here. Taylor had spent the day outdoors at about 5,000 feet in Utah in May. Sunburn can begin within hours and often becomes most noticeable later that same day or the next. So the red marks by themselves do not establish a radiation injury.
And there is a problem with the number itself.
The show never identifies the instrument. Travis calls it my dosimeter device. That sounds like something he wore, not the gas monitor the team lowered into the hole, to check for dangerous gases. And here is the problem. Personal dosimeters usually report radiation in units like microsieverts per hour, millisieverts per hour, or millirem per hour. The show never shows us the units on the screen. The units are supplied verbally, and the instrument itself is never identified. High-range radiation meters do exist. Some can measure several sieverts per hour. But the show never tells us what instrument this was, what it was designed to measure, or what units it displayed. We are being asked to accept a number without knowing exactly what the number represents. And to be fair, there is evidence in the other direction. Two devices are present. They agree on the radiation rate and differ only in their accumulated totals. The men explain that by pointing out that one device was over the open hole and the other was not. That makes a single bad instrument a poor explanation. I am not going to claim that the devices malfunctioned. But notice what the second device actually proves. It makes the displayed number harder to dismiss. It does not tell us what the units were. So here is what I am saying. I don't know exactly what those devices measured. I can't tell you they malfunctioned. But no independent measurement was brought in to confirm the dose, and no biological testing was reported. A routine blood test could have provided useful evidence of a significant whole-body radiation exposure. More specialized chromosome testing could have provided stronger evidence. We never see those results. The point is the size of the claimed number. If the radiation really was that high, the fact that people continued standing there becomes an important question.
Episode 6. Permission to dig is granted. Before the drilling, a local Ute leader, Larry Sespooch, is brought to the site to lay tobacco and offers a warning.
If it's something we shouldn't touch or tap into, your instruments, your machinery will malfunction.
He is speaking within his own tradition, and he is under no obligation to anybody's methodology. That is not what I want to talk about. The editorial decision is another matter. The producers chose to place that ceremony immediately before the one genuine falsification test of the season. So the audience arrives at the test already holding an interpretation of failure. That framing belongs to the edit, not to him. And then the drilling obliges. The bit chatters. A power line shakes. Both are read as significant. Both are entirely ordinary. A bit chatters when it hits harder or more heterogeneous strata, which is precisely what siltstone at 17 feet does, and power lines move in wind and near heavy machinery.
2 holes, 17 feet to siltstone, 29 feet of clay, every core screen, every core at background.
Now, the honest objection has to come first, and it is a real one. 2 boreholes cannot disprove a 1,000-foot target. The holes may have missed it. Converting radar travel time into depth requires an assumed velocity, and get that wrong, and the whole feature moves. Nobody can say those holes went into the thing. But that is not the point, and it never was. The point is what came up. Ordinary sedimentary bedrock, the boring explanation for those radar hyperbolas from the beginning. The null hypothesis recovered in a core tray, on camera. Someone even says it out loud. This does not seem like it adds up to what we were thinking. And then nothing. No revised depth. No second survey. No new target.
What follows instead is relief and a caveat.
Just because we didn't find anything today, that doesn't mean that things aren't going to happen as a result of us drilling.
That is the sentence to hold on to. A prediction was made, it was tested, it failed, and the response is not a revision. It is a reason the failure might not count yet. Notice also what the question quietly became. It went from, is our interpretation correct, to, is there anything dangerous down there? And a negative answer to the second question is good news. That substitution is emotionally natural and epistemically fatal because it removes the cost of having been wrong.
Episode 7. A 2-year-old heifer seen alive that morning is found dead in the east pasture. No external wounds. The team records extreme radio frequency readings at the carcass in a spectrum display in which every band is lit at once.
It's at 5. It's 18. It just jumped to 18 just then. The microwave signals that we measured were as much as 20 milliwatts per meter squared. When I take the same meter and stand in front of a microwave while popping popcorn, it only reads about 2 milliwatts per meter squared.
Start with the microwave comparison because it is the main point of the scene. The investigator says the mystery signal reached 20 milliwatts per square meter. Then he says that the same meter read about 2 milliwatts per square meter when he stood in front of a microwave oven. But those two numbers don't mean what the comparison suggests. Federal rules allow a new microwave oven to leak up to 1 milliwatt per square centimeter, measured 5 centimeters from the oven. That's 10,000 milliwatts per square meter, 500 times higher than the 20 milliwatts per square meter reported for the mystery signal. So the microwave comparison doesn't show that the mystery signal was unusually powerful. The oven test was simply a comparison of what the meter happened to read at that location. And there is an important caveat. We aren't told how far the meter was from the mystery source, or exactly how the measurement was taken. So we can't use the 20 milliwatt reading to determine how powerful the source actually was. It is a power density reading, not a dose. Without knowing the distance, frequency, and duration of exposure, we can't say how much energy a person actually absorbed.
From microwaves down to past the AM and ham radio bands, all of them on at once. Mankind doesn't know how to do that.
As for the claim that mankind cannot produce such a signal, that is simply wrong. Humans have been producing very wideband radio signals for more than a century. Modern ultra-wideband systems can deliberately spread energy across a large range of frequencies, and laboratory equipment can generate broadband signals as well. Early spark gap transmitters were extremely broadband and caused so much interference that they were eventually prohibited for ordinary communications. We did not lose the ability to make broadband radio. We learned how to control it.
A veterinarian performs a field necropsy.
Stress-induced pneumonia. That stress would have been something recent.
The vet's basic diagnosis was right. The necropsy found lung consolidation, which is a common finding in cattle with pneumonia. There was no obvious external trauma, and the animal died suddenly. But sudden death does not mean the illness itself was sudden. Pneumonia can develop before an animal suddenly becomes too sick to survive. Bovine respiratory disease is not an exotic explanation. Respiratory disease is a major cause of cattle deaths, including deaths in adult cattle. There is also a common assumption that pneumonia is mainly a disease of calves. But studies of adult cattle show that respiratory disease is also a significant cause of death in grown animals. So a grown cow dying from pneumonia is not, by itself, unusual. The necropsy gives us an ordinary explanation. It does not, by itself, provide evidence of an extraordinary one.
And the vet was asked what the recent stressor might have been.
I would worry about predators. That could have stressed this cow out. Whatever it was that came and attacked the alpaca.
So the vet named predators as one possible source of stress. And that is a reasonable possibility. But there was another obvious possibility that the show never mentioned. 3 episodes earlier, the ranch brought in about 40 cattle. They were transported, mixed together, crowded into a corral, and run through a squeeze chute to fit trackers. Those are all well-known stressors for cattle. In fact, transportation and handling are closely associated with a cattle respiratory illness, commonly called shipping fever. I cannot tell you exactly how much time passed between those events. Reality television can compress and rearrange events, and I cannot tell you which stressor affected this particular cow. But we do know 3 things. Cattle were recently transported and handled, the cow died with pneumonia, and the show never considered that as a possible explanation. That does not prove the cattle handling caused the illness, but it is an ordinary explanation that deserved to be considered.
And the base rate?
Annual death loss runs about 2.2% of inventory for cattle of that size. For a herd of 41, that is a shade under 1 death a year expected. And the chance of seeing at least 1 in a given year is better than even. A small, well-run herd might do better than the national average. A freshly assembled, freshly trucked herd might do worse. Either way, 1 dead cow is not a number that needs explaining.
The herd was found bunched into a far western corner it had never used.
Cattle can bunch together for several ordinary reasons: heat, biting flies, poor ventilation, light, or perceived threat. Fly-related bunching can produce a different pattern, with the animals grouping together and facing toward the center. But the show describes these cattle as packed into a corner, apparently moving as far away from something as they could. If they were moving away from the film crew, that would fit normal threat avoidance behavior. Then there is the claim that cattle can sense radio frequency energy because they hear higher frequencies than humans. That does not follow. Sound is not radio. For cattle to detect a radio frequency field, there would need to be some biological mechanism that lets them do it. The show never provides one. The microwave auditory effect is a real phenomenon, but it involves pulsed microwave energy. It is not simply an animal hearing a continuous radio signal. So better hearing does not show that these cattle could hear the reported radio frequency signal. The footage shows unusual behavior, but it does not tell us what caused it.
An unmarked helicopter with a gimbaled camera hovers at around 500 feet. It returns no transponder signal.
Not seeing a helicopter on a public flight tracker does not prove its transponder was turned off. Public tracking depends on receiver coverage, signal strength, terrain, and line of sight. At 500 feet, a helicopter in mountainous country can easily be missed by some receivers. And whether a helicopter is required to use ADS-B depends on the aircraft, location, and airspace. So the missing tracking signal tells us very little by itself. Now ask a more useful question. What ordinary jobs involve helicopters with stabilized cameras? Aerial mapping, pipeline and power line inspection, utility work, wildlife surveys, law enforcement, mineral and oil and gas surveys. In other words, a low helicopter with a camera is not automatically mysterious. Before calling it a secret aircraft, the obvious first step is to identify it.
Brandon Fugel brings in the investigative journalist Linda Moulton Howe, who examines the animal.
And here she deserves credit, so let us give it. The animal was intact, no missing soft tissue. She applied her own stated criteria, found they were not met, and said so on camera. It would have been easy and commercially rewarding to say otherwise. She didn't. Her framework, though, is another matter.
She describes a classic mutilation signature: the sky-facing ear removed, the sky-facing eye taken in a perfect circle with the eyelids excised, the jaw stripped, no blood at the scene, and surgically precise incisions.
But every one of those things can happen when a large animal dies, and is later scavenged. Start with the side facing the sky. A dead cow often lies on its side. The side against the ground is harder for scavengers to reach. The exposed side is much easier. Birds and other scavengers simply eat what they can reach. It isn't a surgeon choosing one side. It's exposure and access. Then look at the soft tissue: the eyes, tongue, lips, ears, and udder. These are soft and easy to reach. Scavengers don't have to cut through thick hide to get to them. What about the clean-looking edges? As a carcass decomposes and dries, the hide can shrink and pull back. A ragged opening can then look surprisingly straight and clean. Insects and other scavengers make the openings larger. And then there's the perfect circle.
In May 1979, a New Mexico District Attorney's Office hired Kenneth Rommel, a 28-year FBI veteran. He reviewed 117 reported cases and personally examined about 25 carcasses. One investigator, one state, 1 year. But it remains one of the most detailed investigations of the phenomenon.
The rough, jagged nature of the incisions, together with the evidence at the scene, clearly indicates that the carcass was damaged by predators and/or scavengers. In most cases, the animal had died first of natural causes.
And one of Rommel's photographs makes the point. At Cordova, in December 1979, Rommel noted that an opening looked very smooth from 6 feet away. From that distance, it could easily look like a perfect circle. But the close-up shows something different. The edges are jagged. Coyote droppings were also found nearby. The perfect circle exists when you look from a distance. It disappears when you look closely. That matters because many of these alleged surgical cuts are judged from photographs rather than close examination.
In the absence of blood?
If the animal was already dead, there was no normal circulation when the tissue was removed, so there would be little or no active bleeding. Blood can also settle inside the carcass after death. So the lack of blood does not prove anything unusual. In fact, livestock investigations look for the opposite clue. Blood on the ground can suggest that the animal was attacked while alive. Little or no blood is what you would expect if the animal died first and was scavenged afterward. And the real test is underneath the hide. An attack on a living animal can leave bleeding and bruising in the underlying tissue. Post-mortem scavenging does not produce those signs of ante-mortem injury. That is the evidence that matters. And it is the evidence the show never establishes on camera.
Episode 8. No new fieldwork. Eric Bard steps through the fixed surveillance footage of the cow's death, the footage from the previous episode, frame by frame. While reviewing the footage when the cow died, a flying object is noticed on the video.
The distance from the camera to the trees is how far? It's about 75 feet between the tree that you see on the far right and the next tree. So, if it's directly over the tree line, it moved 75 feet in a 15th of a second.
Listen to that exchange again, because the answer doesn't match the question. He asks how far the trees are from the camera. He is told how far apart the trees are. The distance from the camera to the object is never established. And that distance is the key. A single camera image does not tell you how far away an object is. It tells you how far the image moves across the frame. To turn that into a real speed, you need to know how far away the object was. Double the distance, and you double the calculated speed. The 75 feet is not a measurement of the object. It is the distance between two trees. To use it as the object's distance, you have to assume the object was at the same distance as the trees. So let's keep the footage exactly the same and change only the distance. At 300 feet, the calculated speed is about 767 miles an hour. At 3 meters, it is about 25 miles an hour. At 1 meter, about 8 miles an hour. At half a meter, about 4 miles an hour. Same footage, same frames, same time interval. The calculated speed changes by nearly 200 times, simply because the distance changes. So the footage may show something moving quickly across the screen. But without knowing how far away it was, the footage does not tell us how fast it was actually moving through space.
And the halo the team compared to the Navy videos?
A soft glow around a nearby out-of-focus object is something a camera lens can produce. Video processing and compression can also create halos and ringing around bright, high-contrast edges. So a glow in the image does not, by itself, tell us what the object is. And there is another point about the motion blur. What a camera records as blur depends on how quickly the object moves across the camera's field of view. It depends on angular motion, not speed alone. A distant object can move very fast and still produce little blur. A nearby object can move much more slowly and produce a long streak. So a long streak does not prove high physical speed. It proves that the object moved a large distance across the image during the exposure. Without knowing how far away the object was, we still cannot calculate its actual speed. The halo doesn't prove an extraordinary object, and the blur doesn't prove extraordinary speed. They are visual effects that need to be explained before they can be used as evidence for anything unusual.
The finale's other centerpiece is a terrain model. Eric Bard renders elevation data for the Uinta Basin and proposes that the basin itself works as a parabolic reflector, focusing energy to a point about a mile above the ranch.
The Uinta Basin looks like a very large radio antenna shaped parabolically.
There are two basic problems with that idea. First, a microwave dish has to be very smooth compared with the wavelength. At 2.4 gigahertz, the wavelength is about 12.5 centimeters. For strong mirror-like reflection, surface variations need to be on the order of centimeters, not hundreds of meters. The Uinta Basin is nothing like that. It has canyons, cliffs, mesas, badlands, farms, roads, towns, and thousands of well pads. Its surface can differ from a smooth curve by roughly 100 meters. That is about 800 microwave wavelengths. So the basin cannot act like a giant precision microwave dish. Its rough and irregular surface would scatter the energy in many directions rather than send it all to one point. And there is a second problem: the geometry. Even if we pretend the entire basin is a smooth parabola, about 113 kilometers across and 2 kilometers deep, its focal point would be roughly 400 kilometers away. That's about the altitude of the Kármán line. Now work the calculation backwards. To put the focus just 1 mile above the ranch, that same basin would have to be roughly 500 kilometers deep. That's hundreds of kilometers through the Earth's crust and well into the upper mantle. So even if we give the idea its most generous assumptions, it doesn't work. The real terrain is far too rough to act as a microwave dish. And an idealized dish with the basin's dimensions would focus hundreds of kilometers away, not 1 mile above the ranch.
The season closes with the Utah Attorney General, Sean Reyes, and with a disclosure.
Sean Reyes was genuinely the Attorney General of Utah. He is also a lawyer with no scientific training. His presence signals institutional seriousness. It transfers credibility. It is not evidence of anything.
And then Travis Taylor brings the ranch full circle back to its government agency research origins.
I've been contacted by some folks in the intelligence community that are really interested in what we found. They've measured a similar phenomenon, don't know what it is, and they want to compare notes.
Here, the honest answer is more interesting than either the credulous or the dismissive one. The United States government really did spend $22 million studying this ranch. The Defense Intelligence Agency awarded that contract to Bigelow Aerospace Advanced Space Studies in 2008. And according to internal documents obtained by the debrief, investigators sent to the property were instructed to keep a low profile and pose as researchers from the nearby oil fields. That is remarkable, and it sounded absurd before the paperwork surfaced. It is also the wrong decade and the wrong team. That program ran from 2008 until it was defunded in 2010 under Robert Bigelow's ownership through his company 6 years before Brandon Fugel bought the place. Travis Taylor's own government role is separately confirmed. The Pentagon has stated he supported the UAP task force as a government employee at Army Space and Missile Defense Command. Though note what they also said, that chief scientist was an informal reference, not a title, and that it was not a full-time assignment. And the task force was formally established in August 2020 after this season aired. The Episode 8 claim itself names no agency, no individual, no date, and cites no document. What it has is adjacency to a real history, and that adjacency is doing all the persuasive work.
Before the conclusion, the other column.
This season is not a fabrication, and a critique that says so would be a worse critique. Here is what they got right. 1. Taylor's Nevada fallout hypothesis is a genuine attempt at a mundane explanation for his own anomaly. He got most of the details wrong, but the instinct is the correct scientific instinct, and it is the only time all season anyone reaches for a boring answer first. 2. The Episode 6 drilling was a real falsification test, designed by them, cited on their own prediction, and actually run. Most people who believe something do not go and drill it. They did. The failure was in what came after. 3. The bone verdict in Episode 4 was deflationary and honest. They found something that looked like remains in a sealed room under a farmhouse, and concluded on camera that it was an animal. That is very likely correct. 4. The veterinarian was right, and the show broadcast his answer, even though it was boring. He identified the correct organ, the correct disease process, and the correct causal category, and reasoned correctly that the stressor was recent. He is the one moment the season reaches for a credentialed outside opinion and gets a straight one. 5. Linda Moulton Howe looked at an intact carcass, applied her own criteria, and declined to call it a mutilation. 6. Eric Bard reported the gnaw marks accurately. He saw them, and he said so. That observation is the most diagnostic thing anybody found in that void. And 7, the line that has stayed with me most from 8 episodes.
I am intensely curious about what might be below this ranch, but I do not consider my own curiosity an entitlement to knowledge.
That is Eric Bard. That is a better sentence about epistemology than most working scientists ever say out loud. The tragedy of this season is that nothing which follows it lives up to it.
The obvious response to all of this is that they were doing their best with what they had.
They had a budget, a helicopter, a drill rig, ground-penetrating radar, a resistivity crew, rockets, drones, and a research program running across an entire summer. What they lacked was not money, it was design. Here is what the same resources would have bought. Phase 0, before any hypothesis is announced. Continuous calibrated monitoring for 3 to 6 months. Radio frequency, magnetic, radiological, seismic, optical, at the ranch and at 2 matched reference sites, one nearby, one 100 miles away. Same instruments, same logging, same crew. Now every reading has a comparison population. Now 18 means something, because you know what the number is somewhere else. Phase 1. Write down, in advance and in public, what you expect and what would prove you wrong. If there is a structure at Homestead Two, state its predicted depth, extent, and composition before you drill, and state the result that would falsify it. Phase 2. Blind the analysis. Whoever reduces the gamma data should not know which record is the flight and which is the payload sitting in a field. Whoever reads the radargram should not know which line came from the anomaly. Phase 3. Physical samples go to accredited laboratories with chain of custody. Bone goes to a forensic anthropologist. A claimed 2-gray radiation exposure goes to a blood count, and a chromosome assay inside 48 hours. Phase 4. Log every instrument failure, and log them at the reference sites too. Because here's the thing. Instrument failure absolutely can be data. Whole disciplines are built on measuring the moment a device stops working. But in every one of them, the failure is measured against a known baseline rate. This many devices, this many device hours, this many failures. And here is what the same equipment does when nothing is stressing it. Episode 8 does the hard half of that and skips the easy half. They log the failures. They never log the failures anywhere else. A failure count with no denominator cannot tell a haunted ranch from a bad batch of batteries. Phase 5. Publish everything, including the nights when nothing happened. We are shown the readings that were interesting. We are never told how many readings there were.
So what do you call a research program like this?
The easy answer is to call it unfalsifiable. But I don't think that's quite right. This season shows why. Episode 5 made a specific claim about what was under that road. Episode 6 drilled into it. The claim failed. And before the drilling, they checked the radiation spike again and found normal background levels. 2 claims, 2 tests, 2 negative results. So the individual claims were testable. They could be wrong, and they were. That brings us to what happened next. The philosopher who helps explain it is not Karl Popper, it's Imre Lakatos. Lakatos pointed out that scientists rarely abandon a theory after one failed prediction. A theory comes with other assumptions around it. When something goes wrong, those assumptions can be changed. Sometimes that works. The changes lead to new predictions that are then confirmed. Lakatos called that a progressive research program. But there is another possibility. You can keep changing the explanation simply to protect it from failure. And each time you do, the theory predicts less. Lakatos called that a degenerating research program. Look at what happened here. Episode 5 gave us a very specific claim. A large structure, at a particular location, at a particular depth. Maybe even 2 stories tall. That's a claim with a lot of content. It makes a lot of predictions. Episode 6 drilled there and found ordinary bedrock. So what replaced the original claim? No new depth, no new location, no new target. Just a carefully worded caveat. That does not mean things are not going to happen as a result of us drilling. That prediction is so vague that almost anything could fit it. They went into episode 6 predicting a building. They came out with no replacement prediction, only the possibility that something might happen later. That's the important point. The program wasn't unfalsifiable. Its specific claim was tested and failed. The problem is what happened after the failure. Instead of producing a new, testable prediction, the claim became less specific. The program survived by predicting less. The program went into episode 6 predicting a building and came out predicting that something might happen at some point. That is the whole shape of it. Not a theory that could never be tested. A theory that was tested, lost, and quietly bought itself out of the debt by promising less.
The season ends with the team standing down and pausing their experiments to study what they collected.
There is some phenomena occurring, and we have measured the phenomena. The phenomena is real.
A scientific program takes failure and risks another prediction. A degenerating program takes failure and makes the next prediction harder to fail. The question was never whether Skinwalker Ranch was strange. The question was whether the strangeness could survive a test. Episode 6 gave us the answer. That is the moment it stopped predicting. Everything after it is production. Thank you for taking the time to listen. Remember, we don't teach you what to believe, we teach you how to think. This is the Circle Jerk.